unit 1 less than 13 to us in terms of the total of the unit, okay? This is less than 6 of exponents. Okay, so then here's a brief review. I did hand out that worksheet to you guys last time with the rules on it. If you didn't get one, I'll give one to you, but it just has a list of pretty much these on a piece of paper just so that you can use those to study for and understand them. You don't get to use it on an exam or anything. It's just there for your reference. But anyways, so writing powers as radicals. So if we're going to write these with radicals, we're not doing the actual problem because obviously they're variables, but they're unknown values. So it's just understanding that like A would be 6th root of x. Okay, now B is where it gets a little dicey. Does the exponent affect the negative? Yes or no? It doesn't. So if it doesn't affect the negative, you simply just write the negative still. And now we know it's 4th root of y to the 5th. Or again, you can do brackets to the 5th. Now this time, the negative is included. So that means the negative z goes inside. Okay, so here, the negative just stayed outside. This one, it's going to go inside. So we're going to have negative z to the cube root, and then the whole thing to the 5th. I'm going to mix up. Remember, either way you write this form is fine. Because there's two forms of writing it, just like I stated below in the warm-up here. You can write it like this, or you can write it like this. And in that lesson from Friday that you watched, it says that when it shows you the definition, it shows both ways of writing. So I'll bounce back and forth, unless you guys are adamant you want to keep it one. But okay, so this one would be the same thing as C, but just instead of being on the top, it's going to be on the bottom. It's a negative z in there, sorry. So it's the same exact thing as we have on the left, but it's on the bottom of the fraction because it was a negative exponent. So I pushed it down. Okay. This one, the 3/4, does that affect the 5? No, so we just keep the 5. We write 4th root of t, and then I'm going to do the whole thing this time, cubed. And then f, the 5 is included, so this time we'll go 5t 4th root, and then cubed. I'll write it the other way. Again, don't let me confuse you by writing it. You can write it the same way you like it every time is fine. Okay, I'm just going to try to appeal to everybody. Because some of us aren't going to have to say. Yeah, it's 4 and a 4, yeah. Just sloppy, sorry. Okay, so now we're doing our exponent laws with fractions. Our exponent laws with fractions. So what I mean by that is we're multiplying here. That's a 1. What's our exponent law with these? Add them. So we're going 3/2 plus 1. So we have to do fraction stuff. We have to get a common denominator and add them. Okay, so this would change from 3/2 plus 1 to 3/2 plus 2 over 2 for a common denominator, which would be 5/2. So this is essentially, this section here is just fraction work. Being able to do a common denominator or whatnot. So division, we subtract them. They already have a common denominator, so it's just going to be 1/3 minus 5/3, which is negative 4/3, which means I write it on the what? The bottom. So it's 1 over y to the 4/3. Good job. If you can get that one, you're in good shape. Yep, if you can get that one, you're in good shape. That means you understand negative exponents. That means you can do your fractions. You remember, that's kind of an all-in-one problem right there. Okay, C is which law? Yeah, multiplication. Power to power. Yeah, power to power. So we multiply these. Multiplication is the easiest type of fraction work because you multiply straight across. 1 times 2 is 2. 2 times 3 is 6. We can reduce that to 1/3. So it's going to be a to the 1/3. Okay, we're going to have to go back in a second because it does say it wants us to write as radicals. So we'll do that at the end. Okay, let's finish it out, and then we'll go back and write these all as radicals. Okay, so this time, I have a negative. So who remembers what's the suggested thing to do by the book and by the notes when you have a negative fraction? Yeah. Good. Flip it first. So go x squared over y. Oops, that's not flipping it, is it? Sorry. Y over x squared, and now it's a positive 1/2. So let's explain this. That's a negative, which means we want to push it down. But when you have a fraction, that means flip. So we flipped it, and now it's a positive. And then the 1/2 hits the top and the bottom. So you have y to the 1/2 over x. Why is it just x? Half of 2 is 1. Exactly, Andy. Half of 2 is 1. Because you multiply, I multiplied half to everything, right? Half hit there, half hit there. Half of 2 is 1. Okay? Put it all together. It's a great time for questions, especially if you guys are being gone. And then also because, like I said, this is all inclusive right now. Because a lot of the things we've done over this section. Okay, so I'm going to go back and write these with radicals now. So this is 5 over 2. So it's going to be square root x to the 5th. This one's going to be 1 over cube root y. We'll do the whole thing to the 4th. This is just cube root a. This is square root y over x. Just writing it with radicals like the directions said. Okay, like I said, relatively short lesson. We have 7 example sets. So we're just going through a bunch of examples, which probably some of you guys wanted anyway, so that's good. All right, let's do this last section, the first page. To simplify the following, write each expression as a power with positive exponents and then as an entire radical. Okay, so let's go ahead and do these. So 4 times 3, remember we do multiply the 4 and the 3 because those aren't bases, are they? Right, they're coefficients. Can we please explain, or somebody explain, the difference between a coefficient versus a base? So tell me what would change for 4x to the 3/4 if 4 was part of the base? What would change? It'd be in brackets. This would make it a base. But right now, as it stands, it's just a coefficient because x is the base. It's a very important kind of thing to decipher between. If you can't see the difference or you need help with that, please let me know. That could be a simple mistake. You can make simple mistakes by not knowing that fact.
So you don't times it without brackets.
Right. Okay, so 4 times 3 is 12. We can multiply those. 3/4 plus a negative 1/2. So I got to do common denominator. I'm adding fractions. Right, 3/4 plus a negative 2/4. That's just 3 minus 2, which is 1/4. Okay, if we write this with a radical, 12 4th root x. 1 over 4, right? 12 4th root x. Okay, again, is the 5 or the 25 part of the base? No, so we can reduce this to 1/5. Right? 5 goes to 5 once, 5 goes to 25 3 times. 3/5 minus a negative 3/5. So it's a minus, right? 3/5 minus a negative 3/5. It's 6/5. So we get x to the 6/5. 6 over 5, sorry. That's an exponent. That's pretty low. Let me rewrite that. Okay, x to the 6/5. And so now what we're going to do is we are going to write that as a radical. So we don't really need the 1, so I'm not going to write the 1 for the second one here. It's going to be 5th root of x to the 6th over 5. That's how you can write it as an entire radical. Okay. And the last one here, we got a power to power. So this time, does the 8 get hit by the 4/3? It does. Okay, so the 8 get hit by the 4/3, so we need to get the 4/3 of times to both here and there. 8 to the 4/3 times 4/3 times 1/2. Quick little fraction work on the side. 4 over 6, which reduces to 2/3. Okay, so a to the 2/3. Now we're going to go ahead and write them as radicals. So I'm going to go cube root of 8, and I'm going to the 4th, and I'm going to go a cube root squared. Okay, I'll stop for a second. A lot going on there. So when you have numbers like a, I don't know what a is. I can't do much with a. A is a. But 8 is a number. Can I cube root 8? Yes. Yeah, cube root of 8 is 2. Now I take 2 to the 4th, which is 16. Okay, so I can simplify that down to 16. Cube root of 8 is 2. 2 to the 4th is 16. And now we write cube root of a squared, and that's as simple as it gets. How you feeling, Spencer, for being gone?
Wasn't gone.
Oh, you weren't gone?
No.
Oh, my bad. Who else was gone? How are you feeling, Ridge, for being gone? All right, okay. This is lesson 2 of it. So Spencer should be feeling good then. Yeah. Okay, so we can use the rule here. So a over the m and the m, they're just showing the different ways to write it. So again, back to what I was telling you, Ollie, it shows you right here there's 2 different forms, okay, that you can write it as. Okay, so let's move that up. We have that rule on our previous notes. All right, all this means is just real numbers, okay? So in the form of a at the end, n has to be a real number. So it can't be imaginary, but we won't have any problem with that. So we're writing this as exponents now. Okay, so that means this is going to be a to the 5/3. Cube root on the bottom, 5th on the top. This one here, 2/5. A to the 2/5. That looks like a 9. Okay. This one be a to the 9/2. Remember, if nothing's there, it's a 2. No, it's a 2. If it's not there, it's a 2 for radicals. Because a 1 actually means nothing. The 1 root of something is just, that's what the number. Yep. This here would be 7/2, but what? Negative 7/2. Good. Just negative 7/2, it's on the bottom. Very nice. Okay, so we're going to write these as powers and evaluate. So first off, any questions up here? Okay, so write these as powers and evaluate. So I have 1296 to the what? It's to the 1/2, right? And then again to the 1/2.